So in this section, what we're going to be dealing with is we're going to be dealing with some error handling, as well as controlling whether the tool runs or not using the cell state. And we're also going to deal with calibration, start bringing those units into real-world units so that we actually get some measurements out of it instead of just pixels where that means nothing to us at this point. So we're going to do a nonlinear calibration using the calibration wizard. Like I said, we're going to talk about cell state and error handling. Then we're going to implement those inside our application. Cell state. Now, how cell state works is that you have a cell and it can reference another cell through its cell state. If the cell that it is referencing is a 0, then that means that that particular cell that's doing the referencing is disabled. It will not run, and it will contain the contents of whatever it had the last time it did run. While if it's referencing something that is non-zero, then it will run. Whatever event's causing it to run, it will cause it to run, such as right now, all of our tools inside our application is now based on the acquisition. So when an acquisition runs, then all the tools start to run. What we can do is we can choose which cell we want to control, and we right-click and go down to cell state. Now, all the tools except for one comes into the spreadsheet as being enabled. Okay, just by default, they're enabled. Now, if you pull this up, it allows for you to go in and actually just choose disabled. This can be very helpful if you're trying to comment something out of your program. You know, that you've got some functions running, but you don't want them to run right now because maybe you're trying to troubleshoot. So you can choose those cells and just disable them. Doesn't remove them from your program, just doesn't run them. They will still contain inside those cells the contents that they were the last time that they ran. Now, you can also go in there and choose conditionally enabled. And what conditionally enabled allows for you to do is go reference another cell on your spreadsheet to say, if this is non-zero, it's going to let the cell run. If it's 0, it's going to shut the cell off. So you might say, well, why would I use that? Well, in this case, maybe we want the histogram tool not to run when we didn't successfully find our pattern, that it wasn't above that score that we were expecting. Now, what might be an advantage of not running the histogram tool if we didn't successfully find the pattern? Maybe time? Now, in the case of the histogram, we're not saving much time. Histograms run in like half a millisecond, so we're not gaining a lot of time. But when we start getting into more time-intensive tools, such as OCR Max or some of our flexible flaw tools or something like that, sometimes this can help us saying, hey, if we're not even out there, don't even try. Just punt now and everything, and we're good to go. So if you want to be able to do this, what you would do is you would choose which cell or set of cells that you want to disable. Then you would right-click, go to cell state, and choose your conditionally enabled, and then go to select a cell. Now, it's asking you relative or absolute. Does that matter? Only if you copy and paste. So if you're not going to copy and paste these cells anyplace else, who cares? Just choose one. Then you say select a cell, go out to your spreadsheet, choose that cell. In this case, we're choosing the logic as to whether the score is above 85 or not. So we're going to choose that logic. If that logic shows up as a 1, so it was successfully found, the histogram tool will run. If it's not, then the histogram will, believe it or not, gray out. To some people, when they're looking at the spreadsheet, the blue to the gray isn't quite so apparent, okay, but it does gray out. And then any of the results from the histogram tool will stay whatever they were the last time that the tool ran. So with that said, you can kind of see here, you know, if this goes to a 0, so this spreadsheet showing my logic over there as a 0, you can kind of see this is kind of gray. Believe me, it's gray. There's one problem here that you could potentially have, and it looks like I actually corrected this slide so it doesn't show it. You have to be careful because when you nail that down and you disable that cell, remember the contents are still whatever they were at the last time that it ran. This could give you an erroneous error. You could actually get a false accept. So you've got to be careful now. If that was the case, if I said, okay, the histogram tool is still good, but I didn't find the part, so actually the histogram never ran, what might be a way around that inside your program? And your logic from your find patterns tool with the logic from the histogram. So therefore, even if the histogram said, yeah, I'm good, but that first one said I'm bad, you know, it's bogus information. One of them's bad, it's bad. Don't trust the information. Now, the second thing we want to deal with is pound error. How many people have gotten a pound error? Now, pound error is just letting us know that the tool was not able to run. This could be because it wasn't found, like in the Find Patterns tool, that pattern was not inside my field of view. Or it could be that one of the inputs into the tool was invalid, such as the histogram using the fixturing from the Find Patterns tool that never passed. So all of a sudden it goes to, it's basically being told, hey, go find this over here. And it's saying, where? You've just given me pound errors here. I don't know what you're talking about. So it throws its hands up and it pound errors. Now that's great. Within the program knows everything about pound error. But beyond the program, it doesn't. PLCs don't know what a pound error is. TCP/IP connections don't. Discrete doesn't. So what we've got to do is we've got to clean it up. And you'll notice that as soon as you start getting a pound error, it's going to propagate through your program probably pretty quickly. And you're going to start getting pound errors everywhere. So there are two functions inside the lookup area in the mathematics that's going to help you clean up your errors. The first one is count error, and the second one's going to be error-free. And they both are kind of used slightly different. So depending on your application, you might want to use one versus the other. Now, how count error works is that you can reference a cell or set of cells. And what it's going to do is it's going to tell you how many pound errors are in that cell or set of cells. That's all that's going to do. So it's going to count how many errors you have. So if I said count error of B7, what would it return? Actually, none. There's no errors sitting in B7. Now, if I said count error of C7, what would it return? 1. Exactly. And if I said count error of B7, C7, D7? 2. Exactly. Beautiful. That's exactly. So all that it's doing is it's counting how many pound errors you have within your set of cells. So if it's not an error, it'll be 0. If it is an error, it'll be 1. So it's just kind of, saying, yep, I've got an error there. Or, no, I don't have an error there. Now, how I might use it is this is kind of controlling cell state right here. So right up here, I have a count error of C7. So I'm looking just to see the row of my Find Patterns tool. Now, the truth is, I'm not worried about column and angle, because if my row is pound erroring, trust me, my column and angle is pound erroring as well. I don't care about that, okay? I'm just looking at one cell. So I'm going to count error of C7. If there's an error there, it's going to be a 1. Now what I want to do is I want to knot it. So if there's an error there, there's a 1, and then it turns it to 0. Otherwise, if there's not an error there, it will be 0, which will turn it to a 1. I can now use this 1 and 0 to control the cell state of another tool. And that's how I know that I'm talking about cell state. Anytime you see this italic if, and then it references another cell, that's referencing a cell state. If you look at your formula bar on that cell that's being cell stated, you'll also notice as soon as you do cell state, it adds an italic if to the cell that it's referencing right afterwards. So now basically with my extract histogram, if there's a pound error here, this will be 1, this will go to 0, so it will turn off my histogram. If there's not an error there, this is going to turn to 0, which the not's going to make it a 1. So now it's going to be enabled, and then it will allow the histogram to run. So it's just another way of running about it. It's basically you are getting a number if you have a pound error. If you don't have a pound error, it's going to give you a 0. Other thing that you can use is error-free. And what error-free will do is it will reference a cell or set of cells. If that cell is a pound error, you're going to get a 0. Otherwise, you'll get whatever the data is. So if I have valid data coming through, it's going to let that valid data go ahead and propagate through. Otherwise, if it goes to pound error, it's going to go to 0. So that's how that one works. There's a pound error there, it's 0. Otherwise, it's whatever data you've told it to be. So let's actually try to implement this in our program first, okay? Because we need to clean things up. So one easy way for me to find out what I need to clean up in my program is I put my hand in front of the camera and I hit F5. What that does is it blanks out my image. So I see every place where I'm going to have pound error that I've got to clean up. That's my worst case, is my part not being there. So as I look through it, I see this logic looks fine. That's because Find Patterns is looking at score. Score never goes to pound error. Score will go to 0 if something's not there. Okay, so I don't need to clean this up. But I do see this goes to pound error. I see this goes to pound error. And then I see all of these end up pound error. Okay, so I've got to clean this up. So what I'm going to do is I'm going to go right next to my logic, and I'm going to write in the comment error control. And say OK. And then just because I like things to look a little pretty, maybe give it a little bit of background there. Okay. The command that I want is, I'm saying that when something is good, I want it to be 1, and when it's bad, I want it to be 0. So if I use an error free here, what will happen is that if I actually send in a 1 or a 0, so it's legitimate logic that it's been decided, 1 or 0, those are going to go through. Otherwise, if a pound error shows up there, it's going to be a 0. Now, for me, 0 is bad. Beautiful. I only bring this up because if you're one of the people that 0 is good, 1 is bad, you might want to think count error instead, so that you force it to a count error. Doesn't quite do the right thing, but because you would still have to let the true value through if it's good. But I just want you guys thinking that you have to think about which direction your logic's going in. So I'm going to go over to my mathematics, look underneath my lookup, and I'm going to drag over error free, drop it in, and it's asking me what cell do I want to reference. So I'm just going to reference the one right next to it and say OK. So right now it goes to 0. Beautiful. That's exactly what I want to happen. Okay, if it's pound error, give me a 0. Might be a false reject, but I'd rather have a false reject than letting it through. Now I want to do the same thing for this one. Well, I can make myself work smart, not hard, just by saying copy, paste, and it's all set up. Now you might say, well, how do I know that it's referencing this one? I did relative reference. So since I'm putting it right next to the other one, it's going to reference right to the cell right next to it. Beautiful. That one's all cleaned up. Love it. Now what I want to do, so I control these on the end. Okay. What I want to do here is I want to control it in line. I want to control it serially in the process. So what I'm going to do is I'm still going to go right to that column I asked you to leave me yesterday, and I'm going to go Control V here. And so right now this is referencing the area next to it. Beautiful. I'm going to do the same thing for these two. I could copy and bring it right down, or it's almost the same amount of clicks if I just do this. And add 2 more error frees down to the bottom here. So just pick the cell next to it. Beautiful. But I haven't cleaned up my pound errors yet. I mean, these are cleaned up, but why is the pound error still coming through? The reference is this value is still referencing the area. So I've just got to redirect where it's referencing from. I'm going to reference the error control here. So let me go backwards, choose this one, and accept. So now since it brings the 0 over, 0's outside of my range there. Beautiful. Golden. I'm going to do the same thing here, just reference the one right next to it, accept, and do the same thing to the next one. Beautiful. So now my value is referencing my error control, which is then referencing my area. So if I have a true area number come in, goes right on through. If I have a pound error, it goes to 0, gets chucked out because it's not within my range. All my outputs now are legitimate numbers, and I'm going to be able to use this in my communication. Perfect. So now let's go ahead, and we're going to try this out. So let's go ahead and run it. Everything's passing. Let me kind of go in there and mess some things up. So as I start throwing some things in, I can see some failures in here, as it goes. Now you might see that, do you see how this is delaying a little bit? Like I'm putting my pin here. You don't see my pin yet, and now you see my pin, and yet I'm already away from it. Part of that has to do, we didn't see it as much with the micros and the 5000s as we do with the 7000, because we're starting to get higher res, the cameras and everything, so it's taking a little bit longer. So one of the things that I might want to do just to make things a little bit easier for me so it's not quite so jerky there, is I can actually give myself a little bit of delay here. And I'm going to give myself maybe, let's just say 200 milliseconds of delay for right now. So now if I go into live mode, though it's a little bit chunkier, it's reacting a little bit better. Basically, instead of it's trying to source up some of the information back in its buffers, it's every 200 milliseconds it's acquiring an image. So I'm getting a little bit better results with it than if I just left it on continuous running as fast as possible. So let's have you guys clean up your programs first. Make sure you save it here. Calibration. Now, what is calibration used for? Well, what units are we measuring in right now? Pixels. In pixels, exactly. So if I said something was 108 pixels long, what would you think? Right, you could sit there and maybe think about your application, like on our particular one, where was it 100 or 1024, whatever across, so we could say, that's about 1/10 of our image or something, you know. And if we knew what our field of view is, we could kind of do the calculation, whatever. But if I adjust my height to the part, or skew it a little bit, or what's my other one? Also change my optics, this is going to change. This isn't going to be the exact same again. So what I need to do is I need to get that pixel world into real world so that now I can take a look at my part and say, yes, that is 3 millimeters long, 8 elephants long, whatever you want it to be. So how we're going to do that is we're going to do a calibration. You can do a scalar calibration. For those of you who have used Easy Builder, you see that they have like a scalar point-to-point type calibration. You'll notice the spreadsheet does not have that as a separate tool. That's because you might do something like a find segment tool, find what the distance is. You know that the distance is, let's say, 100 pixels, and you know that it should be 3 inches. So, okay, so it's how many pixels per inch, you know, so 100 over 3, that's your conversion factor, and then you would just apply it to any of your measurements from there. That's great, except for that's not very accurate. It's only going to be accurate right at that area which you actually did the measurement. As you start going around the field of view, it could be thrown off. This could be because you have lens distortion, and the lens distortion can come from not having the correct lens matched up with your CCD or just using a poor quality lens. As you start getting towards the edge of it, it starts taking on a fisheye look. So things look like they're actually starting to pull away from it. You could also be in a situation that you can't be completely over your part, that you have to go to the side because maybe you have equipment sitting up there. Okay, so everything's going to have that. Some people call it perspective distortion. Technically, it's skew distortion. It's that kind of trapezoidal, you know, as things are going away from you, kind of like a train railroad. And then you could also have the situation which is true perspective distortion, which is where you have a 3D object coming up at the camera, and just how light works is anything in the center is going to be right on the axis, so it's going to look like it's coming right at you. But as you start going away from that center point, that center axis, it's going to look like it's splaying away from you. Now, if you use a telecentric lens, you can take this out. But if you're not using a telecentric lens, this is just a property of optics. This is just what happens. So what we want to do is we want to make sure that our accuracy, which your best accuracy for a lens is always going to be the center. That's your sweet spot on the axis. That we want to make sure the accuracy as we get away from the center is going to be just as accurate as it is in the center. We don't want to have to worry about, oh, you know, was this all taken into consideration and everything? We want to just calibrate our field of view. So one way that we can do it, because there's a variety of ways to do calibration but we're going to use the calibration wizard. Now, what's a wizard? It's a step-by-step, let me walk you through the process to get you there. So that's exactly what ours does. Our wizard is going to have 3 different fields here that's going to help walk you through the process of setting this up. Now, it is called Calibrate Grid. And so what Calibrate Grid means is I've got to use a grid calibration. This grid calibration can either be grid of dots or it could be checkerboard. And it can be with or without fiducial. So fiducial, what is a fiducial? It's a locator. It's some type of registration point. In the case of calibration, it's going to denote where your origin point is as well as where your axes are. So you have your choice here when you're choosing what type of grid type you're using. Are you using a grid of dots or the checkerboard? And are you using it with or without a fiducial? So you choose which type plate you're using, and then you go on to the next step. And the next step is going to say, what is your grid spacing? Now, your grid spacing should be written on your calibration plate or on something that's given with your calibration plate. They will tell you what it is. For checkerboards, it's the distance of each checkerboard. For a grid of dots, it's the distance between centers of the dots. So you need to know what that value is. Then it asks you units. Really, it only gives you 4 units. It gives you like millimeters, centimeters, inches, and what's the other? Microns. The truth is it really could care less what the units are. Okay, if you could measure things in drafts, you could do that. It's the actual value there. That grid spacing is the most important because that's what's doing the mathematical transform behind the scenes. The spacing is just for your sanity, or the type, just your sanity, the units. Once again, Insight could care less what the units are. So if you're sitting there saying, well, I'm actually using it in meters for some reason because maybe you're looking far away, but there's not meters here. Don't worry about it pick one of the units, just make sure you say what the real meters are, and you're good to go. Then what you would do is if you need to print the calibration plate, you can print it. Okay, just print it on out, try that out. Beautiful, that's awesome. Your printer might define how small you can get that calibration plate. We were playing with it before and we had it pretty small, and our printer just wouldn't go any smaller than that. But it does give you a nice down and dirty to be able to at least try a calibration plate in your lab just to make sure stuff's looking good. Now at this point, it would ask you how many poses you want, and I'll talk a little bit about poses in a moment, but it's basically each time you take an acquisition for it to recalibrate. Okay? So we're just going to go with one pose, one acquisition there. So then we choose pose on the left-hand side, and it's going to come up and it's going to say, okay, well, how are you going to get that image? So if I have nice mechanical stops for my calibration plate, I could just put the calibration plate in there, say manual, one shot, boom, finds where the corners are. But otherwise, I could say live, position my plate underneath there, then come out of live, and it will do the same thing. Now, would you ever use from file? When you're doing calibration, you want your live environment. Bringing in an old image does nothing for you, okay? Does nothing. Because then you're calibrating on how it was then. That's not what it is now. If you slightly moved the camera or it got moved down a little bit or something, you're not taking that into account. Now, you might say, well, why do you have a from file? Remote support. If you're helping someone, maybe they're in Portland, they're having a hard time putting stuff together, you say, take an image of the part, take an image of the calibration plate, send me both at that same, don't change the camera during that, and I'll fix it for you. So now you can bring in what their image is, set it all up on your emulator, fix them up, and then send that back to them and say, okay, this should take care of you. So what's going to happen is if you're using checkerboards, it's going to put little green X's at every place the checkerboards touch. And if you're using the grid of dots, it's going to put little green X's on each of the centers of the green the dot. So it's letting you know which points it took in. Beautiful. It'll also print out what the points are. It'll tell you what the pixel points are as well as what the real world points are. If you click on any of these on the table, it'll show it up in pink on your image. If you click on any of the points on the image, it'll show you where they are in the table. So you can kind of check, double check, make sure it's looking good. Also, if you need some type of offset, or if you did not choose fiducial, you're going to need to decide what that center point is and where your axes are at this point. So if you're using robots, you can add in what the robot offset is here. So it knows to adjust accordingly for it. Now, if everything looks pretty good for you, you would hit calibrate at the bottom, and it's going to take you to the final screen, which gives you quantitative and qualitative information about how good the calibration is. It's going to tell you what your average error is as well as your maximum error, because it's taking into account any distortions or anything inside your image. So now you can see, hey, is this going to work for me? Now, does every application require calibration? No. No, there are two types of applications that require calibration. What are they? Measurement. Yep, measurement requires relative calibration. What's the other? Gave you a hint there because I said relative. Robot. Robot requires absolute. Because if I'm just doing a measurement, where my center point is really doesn't matter. Okay, because if I measure here, same measurement. Boom, boom. But if I'm doing a robot, I need to know where that position is in the real world. So that's where I place that center point becomes very important at that point. One also thing I should caution, we're going to be using paper calibration plates here. They're not going to be the best. The larger the res camera you have, the less forgiving it is on poorly printed calibration plates. So why I'm saying this is because when we do this, you might get a good to a marginal rating. Don't think the camera's acting bad. In fact, the camera's acting good. That the higher the res, because we started finding these out when we got to 7,000s, which is almost twice the res as the 5,000s we were using, all of a sudden we started coming up with marginal. I used to have excellent. Now I'm getting marginal, and that hurts my pride. But as we look at it more, it's because they're far less forgiving of a poorly printed calibration plate. Why wouldn't paper be your best form of calibration? Can bleed out, depends on that printer. Yep, what else? Humidity can change it and everything. The ink can bow it. Could be not flat and everything like that. So it's not the best medium. Usually calibration plates for high accuracy are either written on aluminum or glass. Okay, and they're usually laser etched. The more accurate that you have, the more money these calibration plates are. But like I said, we're going to use paper because it'll do for this class. Now, there might be a reason that you want to use multi-pose. Remember, I just said I was using one pose. I'm just taking one image of it. But there might be a reason I want multiple images of it. It might be that I have a very large image. So maybe I'm doing a car door, and those calibration plates get pretty expensive. So even for like a paper size one, I might have to put it around the field of view. But each time that offset's going to be very big because I have to know what they are relationship to each other. But I can do multiple ones around my field of view. Or if I have just a really highly distorted image. And by getting more points, the more accurate it can get. So maybe I do the calibration plate there and then maybe move it down and over maybe 1 inch, just so I have a different set of points. And then it's picking up those and it just gives better accuracy that way. So now what we want to do is we have a little calibration object sitting on our spreadsheet not doing anything. Has not changed any tools, it's just sitting there. So now what we need to do is we need to have a way of bringing it to the tools. Now there's a few ways to do it. But the simplest way I'm going to do it is called calibrate image. And calibrate image, what it does is it's going to ask you for an image and then a calibration. So the image, in this case, we'll use A0, the acquired image coming from the camera. And the calibration, we're going to go reference that grid calibration we've just created. So now what's sitting in the spreadsheet is this little image object. Now what I can do is go back to my function that I want to use, that I want to convert to real-world coordinates. And where I was looking at the pixelated, the acquired image, I now go reference the calibrated image so that the results coming out of it, instead of being in pixels, it will be in whatever units you calibrated it to be. Now there's a caveat with this. This really should be the end of the line for you. What do I mean by that? What I mean by that is you are all done with this tool and now you're pushing out data. This tool's not really being used anyplace else. So in the case of our edge tool, that's true. We're just measuring it and then we're done. So we can calibrate the edge tool. What about the blob tools? Well, what's their units right now? Square pixels, because they're an area. We can calibrate that. We'll have them in square units. Beautiful, that's fine, because all we're doing is looking at areas and pushing them out. Histogram, should we calibrate that? Exactly, exactly. You are picking up grayscale values. That's not calibrated. Yeah, so it's not going to do anything for that. It's going to say, whatever, my grayscale is still my grayscale. Now, your fine patterns tool, do not calibrate that one. The reason you do not calibrate that one is that is an input to the other tools. All the inputs to tools are expecting it to be in pixels. So if all of a sudden you calibrate it and then you feed it into another tool, the tool's going to think it's pulling that in pixel coordinates, and next thing you know is your regions are doing these really odd things on your field of view. Now, since we're only using the fine patterns for fixturing, that works fine. But if you needed it to also spit out what the real world coordinates is, then what I would do is copy and paste it, take the second one, calibrate that, and leave the first one set in pixels so it can still control the others. The only gotcha on that one is if you change one of the functions, you need to make sure you change the other. Otherwise, you've just disconnected them from each other and they won't be doing the same thing. So how accurate is your vision system? Well, think about the parts you're inspecting. Smooth edges are going to give you better measurements, while if you've got some burrs and everything it's going to make you think that you have some roughness. And we've already talked how that could throw off your edge tool. How accurate is your calibration grid printed? We talked a little bit about having the paper one before. So we want to make sure that if we want some high accuracy, we're going to need to invest in very good quality calibration plates. How good is your lens? Want to make sure that you're using a high quality lens so you're not taking in extra distortion when possible. Also, if you can use a telecentric lens, even better. Because a telecentric lens is not as dependent on how close or far you are from your part. It's going to keep it the same type look and feel no matter how close or far you get from the part. How well is your camera mounted? Well, if you're on vibration or something like that, the camera could slightly turn a little bit and that could throw off some of your measurements. You also want to know what's the image quality. Okay, we talked a little bit about blooming yesterday, that oversaturation. So we said if that's right on an edge, well, that can move the edge. If that's moving the edge, then that's going to move your measurement, which could give you a hard time. Also, if you start messing with the gain, you can get access to the gain, and what the gain does is kind of increase the contrast of your image. But what happens is you can get this thing called pixel jitter, which all of a sudden a particular pixel might be above whatever the gain is, so they either snap it up to white or snap it down to black. What could happen if that's right on an edge? It once again looks kind of like a rough edge, and you're back to the first issue. What do we say for our tools? We quote our tools as being a 1/4 pixel accuracy for edge tools, a 1/10 of a pixel accuracy for fine pattern tools, and PatMax can get down to a 1/40th of a pixel accuracy. So it can go very, very accurate. Keep in mind, these tend to be additive. They very rarely will cancel each other out. And also, we're saying that these are on ideal parts. Nice, smooth, great images and everything. So when I'm trying to get a 1/10 of a pixel accuracy and fine patterns, it's because I've got a really good part there. PatMax can do a 1/25th of a pixel accuracy with no problem. It's getting down to a 1/40th. You've got to start controlling your light, controlling your lenses, controlling how it's presented to it. And then finally, bottom line, test it. It's your app calibration, test it. I had someone say, well, I don't want to calibrate. You know, calibrate is such a pain. I said, okay, well, test it. Put something of known dimension underneath it and test it. If you're not within your tolerance, then you're going to have to calibrate. Now, whenever we do the calibration, I used to joke about this in class, and now it's become a non-issue, is that we used to have flat plates that we would use, or flat gaskets. And so always someone would take because you have your calibration plates at the end of your book, they take their book, put it underneath there, acquire it, take their book out, put the plate back down there, and it was measuring wrong. It's a different distance, exactly. You want your calibration plate to be at the level at which your part is, at the part that you're inspecting. Now, why I say it becomes a non-issue now is your book is about as high as your part. So it starts becoming, you know, a non-issue with these particular parts now. But make sure it's at the same level. Now, I had people say, well, what if I'm measuring something down on the bottom and then I'm measuring something up at the top? Well, first thing to keep in mind, this is a 2D system, not a 3D system. So if you're trying to do these triangular calculations from there, you're on your own. Otherwise, if you're measuring something down here, do a calibration down at this point. If you're measuring up here, do a calibration up at this point. So those tools down here would use that calibration. Those tools up here would use this one. So you can have multiple calibrations within your program. Beautiful. Now someone said, well, what if I have them pretty close? Well, you could once again do 2 calibrations, or you could say, I don't need that type of accuracy. Split the difference. Put it right in the middle, and then they both have the same type of inaccuracy on both sides. It's up to you. Depends on your accuracy. Now, when you're trying to decide on a camera, I always caution people to stay away from hour limits. So like in our program, we have an edge tool. We have a fine patterns tool. So we're talking about less than half a pixel of accuracy that we're having to hear. Now, when you're dividing out what your tolerance is, you should make sure your tolerance, if you're plus or minus 3 microns or something, let's say, make sure those 3 microns equal to about 5 pixels. I say 5 pixels because that gives you some wiggle room. That means you are well away from our tolerance there. So the information you're getting back, you can trust. Now, you might come to me and say, but 5 is kind of high. Could I do 1? I'm going to say it's completely dependent upon your application. In our application, we might be able to get away with 1. What we're doing right now. But if I start adding a few more tools, that might get blown out of the water. So I have to think about, once again, adding these things on, because I have a fine patterns tool that then's controlling an edge tool, so those two are going to add together. That's what I have to think about. So I want to stay away from the camera's tolerance. I want mine at least above it, so I feel more comfortable with the measurement getting out of it. And then they ask, how often should I calibrate? At a minimum, you should calibrate whenever you physically change the camera, or at least test it. If you don't want to calibrate, at least test it. So we've talked a little bit about cell states, allowing you to enable and disable cells on the fly. We talked a bit about the error handling, so that we can find those errors and clean them up. We talked about calibration, getting those pixel values out to a real-world value so we can do something with it. And we talked about how we can get rid of some of the distortion that can be built into our calibration, as well as Calibrate Grid deals with non-orthogonal mounting. So that's when you have to go off to the side. And finally, you want to make sure that you calibrate when you have any physical change to your environment. So let's try this out. So I'm going to comment, and I'm going to call this calibration. Give it a little bit of a background. Up. Okay. So the first thing that I want to do is I want to add a calibration grid. Okay, so I'm going to go down to coordinate transform. So let me just closed text, I was using that earlier, my mathematics. So I'm going to go down to coordinate transforms, underneath calibrate, and I'm going to look for calibrate grid. Drag and drop that into my spreadsheet. Now it's going to come up. We can do checkerboard with fiducial, just a checkerboard, dots with fiducial, or just a dots. So what I'm going to do is I'm going to go to the smaller one. One of the reasons we need the smaller one is we pick up enough points. So I'm doing the smaller grid size that we have here. So this is actually a checkerboard with fiducial, because that's what that little like L-type shape thing is, a little fiducial mark for it. So I'm going to say checkerboard with fiducial. The grid spacing on mine is 5 millimeters. So let me change this to 5. And I can leave this as millimeters. Now, once again, it doesn't really care the units. This is just for my sanity. When I look at it, I'll say, oh, this person did it in millimeters. OK. So now if this is all set up correctly, I only want one pose, and I'm using a round lens. So I'm going to go to pose now, and it's going to let me get the image. So let me go ahead and say live video, because I don't have something straight on. But this is where that's going to throw me off a little bit. A little tough. I'll do this. Understand mine's a little off doing this. I don't want to rip up this book. That's why. Otherwise, I would rip my piece of paper out. Since I asked for the fiducial, I need to have the fiducial in there. If you don't ask for the fiducial, you don't need to, but you've got to tell it where it is. OK, let me comment on this fiducial. This is really bad calibration, by the way, but let me just comment on this fiducial. How it works is this long line right here is going to be your y-axis. Okay? The short line is going to be your x-axis. If I take the edge of each of these lines and pull them together, so that point right here is going to be my origin point. This is not a Cognex standard. This is an industry standard. I just like to explain it because I know the first time I looked at a checkerboard calibration grid, I was like, where are you pulling the origin point from? I like to explain it a little bit. This is not a good paper they printed it on either. So, OK, so caution right now, I really should have this up a little bit or be using a telecentric lens. So I'm already telling you, I know this is not going to be an accurate one. But we'll all have the same inaccuracy. How's that? So what, now the fact that my point, my center point is going to be up here, who cares? I'm not doing robotics. So I don't need to like make sure this is in the center of my screen. I just need to make sure that it's contained in my field of view. So now at this point, I'm going to go ahead, come out of live mode. And if I take a look at this, it has found 111 points. Now you'll notice that there's a couple places it doesn't have a point. Okay? Didn't calibrate there. That's because I have so much glare there, it wasn't sure what to do with it. So if you are going to be doing some major measurements in this area, you might want to go back, change your lighting and your optics and stuff to get better contrast in there. Since that's not where I'm doing my measurement's in the center, who cares? I'm good with this. Okay? So if I choose any of these points, it shows me where it is on my table. If I choose anything on the table, it shows me the point on my graph. Okay? So I kind of have that choice. Now, if I did not choose a fiducial, it's going to give you a couple of extra selections down here that you have to say where your origin point is, where your x and your y axis. Okay, and it's going to ask you to pick a couple of points to define that. Otherwise, everything looks great. I don't need to do any offset. So now I'm going to say calibrate, and it goes chug, 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 and it lets me know that I have good calibration. It's saying my average error is a little less than half a pixel, but it could get as bad as 1.2. Because, well, it's letting me know because I've got a lot of distortion in here and everything, and it's not that greatest of lighting and optics that I could get as bad as 1.2. So at least I know that, and I want to make sure that I keep my tolerance away from that 1.2 pixels. And it says good. If I used an actual laser etched calibration plate, I'd have excellent. But that's how this was manufactured. It's, like I said, higher the res, the more it's picking up your little small defects in it. But I'm happy with good. You know, the marginal starts making me a little OCD, but I'm fine with the good. So I'm going to go ahead and say OK here. And now what's going to end up on my spreadsheet is now I have a little calibration object just sitting there, little calibration object. Beautiful. So now what I want to do is I want to convert that. I need to be able to have some way to bring it into my tools. But notice none of the tools had something that said calibrate on it. So what I want to do is I'm going to take the easy way out. I'm going to do calibrate image, drop that in where it asks me what image do you want to use. So the image I want to use is A0. The real rule of thumb is the image you should use is the image that the tool was using. In our case, our edge tool was using A0, so that's the image we're using. And then what is your calibration? Well, I'm just going to double click on the word calib, choose the word calib that's actually sitting on my spreadsheet and say OK. So when I look at this, I say image, image, calib, calib. Everything looks great. I don't see any red marks, saying, whoa, what are you doing? So now as soon as I say OK, I have an image sitting there. So now we're back to our image and to do our calibration. So right now, notice my distance up here is in pixels. What I want to do is I want to get out the real world coordinates. So I'm going to go to my edges. And where it says image, instead of referencing A0, I'm going to double click on it and go reference that calibrate image that I've just created and say OK. Now, note the 841, that's in pixels, right? Watch what happens as soon as I say OK. Now it's 48 millimeters. So it's coming out in real world coordinates. But notice my logic is saying 0. Okay, why is my logic saying 0? It's a good part. We had set it up so that it was in the pixel range instead of the real world range. Now what we can say is, let's say it should be 48. And let's say it's plus or minus 5%. So that would be plus or minus let's just say 2.5 to make it easy, 2.5 millimeters. So if our ideal is 48, our low point might be 45.5. That's 2.5 millimeters less than that, so 45.5. And our high one might be 50.5. Now, mind you, this is not off of what I've just measured now. This is off of what I know the tolerance of the part should be. So now if I go ahead and say OK, note that this is now a 1. Beautiful. Let's confirm that it works. That's my good one. Take this out of the way. Let's put my bad one underneath there. And sure enough, it's reading it at 51.8 millimeters. Okay? So now it throws that one out.